Good morning, grade 5s, and welcome to our NST lesson for today. Today we're going to have a practical lesson, and I know you enjoy practical lessons. Our last practical lesson was on the decalcification of bones. Remember when we had bones in vinegar, and we also had some bones in water. But before we move on to today's work, we need to do our corrections as usual, and these are the corrections for activity 6, which was on page 69. I did send these on the D6. I also sent them through email, but those of you who did not check the corrections, they are on the screen now. You can pause the screen and mark in pencil. Remember, if you get any of these wrong, you do your corrections in pencil. So our lesson for today is going to be about ways of investigating or investigating ways of making dull metals shiny. That is our aim for today's experiment. We want to find out ways of making dull metals shiny. But before we move on to the rest of the experiment, I think it is of paramount importance that I discuss the words that we are going to be using. Okay? Rust, for example, that is a word that we have come across, and we said that it's the reddish brown layer formed when iron combines or reacts with air and water. And I did give in my previous lessons examples of how corrugated iron rusts if it's not protected, and that corrugated iron is hammered in sheets, and then once that is done, you dip the whole sheets in zinc, and then it becomes plated. Okay, so when something is plated, it means it is covered by another metal to stop it from rusting. And then tarnish is a new word. Tarnish is when a shiny metal gets a dull appearance. There are certain metals that do not rust, but these metals will lose their luster. They will lose their shine. Metals like copper, for example, bronze, nickel, if you expose these metals to weather elements, they are going to lose their shine. So we say that they tarnish. Okay? And then plated is a metal coated by another metal. All right. So we often make objects from cheap material, as you can see on the slide there. I said we often make materials or objects from cheap metals, and then we add a shiny, more expensive metal on the outside so that it looks beautiful. I'm sure some of you have gone to certain shops and you say, oh, this is a beautiful necklace. It's all shiny and all. Then you buy the necklace, and after a week or two, it starts losing its shine. Okay? So we say that these items are plated. They've got one metal on the inside, and then they've been covered with another metal on the outside. Our South African coins are plated, and our 5-cent coin is actually made out of steel and then plated in copper. Okay, so steel is the cheaper metal. Okay, so they are made out of steel, which is quite cheap, and then we have the more expensive shiny metal on the outside, which is our copper. So steel is less expensive than copper. Then we've got our 10 cents, 20 cents, and 50-cent coins. These are also made out of steel, but they are plated in bronze. So copper is less expensive than bronze, and then steel is less expensive than bronze. Then we've got our 1 rand, our 2 rand, and the old 5 rand coin. These ones are made out of copper. Yes, they are made out of copper, and they are plated in nickel. So nickel is more expensive than copper. So when we look at these coins, after they've been manufactured, they look so beautiful. They are shiny, they've got the luster, and but then they change with time. Okay, so before we find out why these coins change with time, we just need to look at why scientists do experiments. Okay, scientists are always trying to find out more about the world and about why and how things happen. They usually start off by observing things, and then they ask questions. So, to answer their questions, they normally conduct a scientific investigation, or they do a scientific test, or they do a scientific experiment. Scientists are always following a careful plan when doing investigations, and you'll find that all of them follow a certain plan. Like as we speak right now, there are scientists out there, medical doctors, scientists who are sitting down and asking questions. Okay, they've asked the questions, they've seen what is happening out there in the world, and then now they sit down and they want to find out, for example, why this coronavirus behaves the way it does and what can be done to stop it. Okay, so that's how scientists get to conclusions. That's how they find solutions to problems, by sitting down and following certain investigation steps in order to find problems to a solution. So these are some of the steps that the scientists follow. And we've done this before. Our first step is the aim. And the aim is, what is the purpose of the investigation? Why are you investigating? Or what are you investigating? Okay? And then our next step is the hypothesis. Remember, I said the hypothesis is an intelligent guess. It's a good guess about what you think will happen in the investigation. It doesn't have to be correct. Remember, you are guessing. So obviously, if you are guessing, it's either you are right or wrong. All right? And then the next point is our apparatus and materials that we are going to use in the experiment. And these could be your tools, your equipment, the chemicals that you're going to use during the experiment. And then our next step is the method. Method, these are steps to follow in conducting the investigation. What are you going to do? So you list your steps in order. Okay, step 1, this is what you're going to do. Step 2, step 3, step 4. And then you have your observation. Observation, these are comments based on information gathered through your senses. So as you are doing the experiment, what do you observe? Okay, so normally certain experiments will take 3 days or 4 days or 10 days, okay, in order for us to be able to observe what happens. But today's one is going to take 10 minutes. And I'm going to have the video in 2 parts. So we'll have the first part, then break, and then have the 10 minutes, and then come back and continue with the video. All right. And then our next step is the conclusion. All right. When we look at the conclusion, we are saying, from the experiment, what did you decide? Okay, what you decide based on the results that you have gathered. So after the observation, what have you gathered? What have you learned? Okay, and then you have your evaluation, where you ask the question, was my hypothesis right? Was my guess right? All right, so some of you will have the right guess, some of you will have the wrong guess. There's nothing wrong with that. You will not lose a mark for getting your hypothesis wrong. And then if you had to do the experiment maybe all over again, what would you do? Okay, so that is what evaluation is all about. And then your next slide will be your observation sheet, or observation, the results that you got. Okay, and from this sheet I said that you must draw the table and fill in the results, compare the shine of the coins, and then you rate your coins from 0 to 4. 0 means it's still down, 1 means a small amount of shine, 2 a little more shine, 3 it's shiny, 4 it's very shiny. Then the last one, this is the sheet that you need to complete. I know maybe some of you don't have printers, but it's okay. You can do this in your exercise book. You can copy, aim, and then you tell me what your aim is. And then hypothesis, you tell me what your hypothesis is, and so on and so forth. Okay, so now I'm going to go to the experiment. Remember, I said the experiment is going to be in 2 parts, because we've got to wait for whatever we are doing. We've got to wait for our coins to react. So they need a good 10 minutes to do that. So I will video the first part. Okay, I'll video record the first part and then stop and wait for 10 minutes, then come back and do the rest of the video. Okay, thank you for listening. Goodbye for now.